Hello everybody, welcome back to Mathlete's Corner. I know it's been a long time since I posted a video, but we're back with a really interesting topic, combinations and permutations level 1. Now, if you're not already familiar with the basics of combinations, permutations, what they are, then I'll link my previous math counts video on this topic in the description below. So you can go check that out. But once you're done with that, come right back to this video because we're going to be looking at some really cool AIME problems. So let's get right into it. So our first problem is the 2017 AIME 1 problem 1, and it reads 15 distinct points are designated on triangle ABC. The three vertices ABC, three other points on side AB, 4 on BC, 5 on CA. Find the number of triangles with positive area whose vertices are among these 15 points. Now to approach this problem, let's just really quickly get rid of this condition here that our triangles need to have positive area. Right, so let's allow triangles with an area of 0. Now we're really just looking for how many ways are there to choose 3 points out of our 15 points, because any 3 points will create a triangle. If this were the question, our answer would just be whatever 15 choose 3 comes out to. Now, the unfortunate part is that's not our question. Clearly, we need to subtract something out from our 15 choose 3. The triangles that we need to subtract are the triangles with area 0. So now we have to count how many triangles can we find with area 0. And the only way for that to happen is if the three vertices of our triangle lie on the same line. So then we'll get 3 other combinations to subtract, one for each of our sides of triangle ABC. Now let's start with side AB. Other than points A and B, we have 3 points, so a total of 5 points, and choosing 3 of them gives 5 choose 3 triangles with an area of 0. Now the same thing on BC similarly gives 6 choose 3, and CA similarly gives 7 choose 3. Now at this point, we just have to evaluate this to get our final answer. So 15 choose 3 is 15 times 14 times 13, all over 6. 5 choose 3 is 10. 6 choose 3 is 20. 7 choose 3 is 35. And I really encourage you guys to memorize those for competitions. So when we cancel out this fraction here, we get 7. Here we get 5. So it comes out to 5 times 7 times 13, which is 455. Then we subtract 10, 20, and 35 to arrive at our final answer of 390. Now our next problem is the 2015 AIME 1 problem 2, and it reads the 9 delegates to the Economic Cooperation Conference include 2 officials from Mexico, 3 from Canada, and 4 from the United States. During the opening session, 3 of the delegates fall asleep. Assuming that the 3 sleepers were determined randomly, the probability that exactly 2 of the sleepers are from the same country is m over n, and as usual in AIME problems, we have to find m plus n. So I think in this problem, it's way easier to find our total number of possibilities than our successful number of possibilities. So let's first look at our denominator. So let's put the fraction bar through. And our denominator is just how many ways are there to choose 3 people from a total of 2 plus 3 plus 4, which is 9 people. And choosing 3 from 9 is just by definition 9 choose 3. Now our numerator is a little more complicated and takes a little bit more work. So we'll have to split on 3 different cases. Our first case will be 2 sleepers that are from the same country are from Mexico. The second case will be 2 sleepers from the same country from Canada. And our third case will be 2 sleepers from the United States. So when we work that out for our first case, we have to choose 2 from our 2 officials from Mexico. So that's just 2 choose 2. And the third sleeper may be from Canada or the United States. So there's 7 choices there. Now, similarly, in our second case, there's choose two ways to choose the sleepers from Canada, and there are 6 ways to choose the third sleeper. Now, our third case, choose two ways to choose the sleepers from the United States, and 5 ways to choose the third sleeper. And now we've come right back to evaluation, where we just have to work through each of these combinations and determine our final answer. So we do that. The numerator comes out to 2 choose 2 times 7 is just 1 times 7, plus 3 choose 2 times 6 is just 3 times 6, so that's 18, and 4 choose 2 times 5 is just 6 times 5, so that's 30, all over 9 choose 3, which is 84. Now this evaluates to 55 over 84. We can't simplify this further, so we just add our numerator and denominator to get our final answer of 139. That's all for this video. Thank you for watching. Don't forget to hit that like and subscribe button, and I'll see you next week here at Mathlete's Corner.